What if Earth suddenly stopped spinning? Picture this. You're sipping your morning coffee, scrolling through your phone, when suddenly everything changes. Not gradually, not over centuries, but in an instant. Earth's rotation, that constant 1,038 miles per hour spin we've relied on for billions of years, comes to a complete halt. This isn't science fiction. This is physics at its most terrifying. Right now, as you watch this, you're traveling at approximately 465 meters per second if you're at the equator. That's faster than the speed of sound. You don't feel it because everything around you moves at the same speed, held in place by gravity. But what happens when that cosmic dance suddenly stops? The answer is simple. Chaos unlike anything humanity has ever witnessed. The catastrophic reality. The first few seconds, unstoppable force meets immovable object. When Earth's rotation suddenly ceases, Newton's first law of motion becomes humanity's worst enemy. Everything not anchored to bedrock, including you, every building, every car, and the entire atmosphere, would continue moving eastward at the planet's original rotational speed. At the equator, this means supersonic winds of 1,038 miles per hour would instantly scour the surface clean. For perspective, the strongest hurricane winds ever recorded reached 253 miles per hour. These winds would be 4 times stronger, turning every loose object into a deadly projectile. The destruction wouldn't be limited to the equator. Everyone living between 42 degrees north and 42 degrees south, roughly 85% of the world's population, would experience sudden supersonic winds. Even structures designed to withstand extreme weather would crumble like sandcastles. The sudden stop would trigger massive earthquakes as Earth's crust reels from the momentum shift. The change in rotational forces could generate seismic activity unlike anything in recorded history. Massive tsunamis would follow, created by displaced oceans that had been held in check by the planet's spin. But here's where it gets worse. Earth's shape itself would begin to change. The Great Reshaping. Earth isn't a perfect sphere. It's an oblate spheroid, bulging at the equator by approximately 21 kilometers due to centrifugal force. This bulge exists because our planet spins. Without rotation, gravity would begin pulling this excess material back toward the poles. The result? A catastrophic redistribution of the world's oceans. Water would migrate from equatorial regions toward the poles, potentially dropping ocean depth by 8 kilometers around the equator. Since this is less than the actual ocean depth, Earth's water would be divided into 2 massive polar oceans separated by a belt of land around the middle. Entire continents would emerge from the sea around the equator, while everything north of Spain and all of Antarctica would be underwater. The familiar world map would become unrecognizable overnight. The 6-month day. If Earth somehow survived the initial catastrophe and continued orbiting the sun without rotating, each day would last 6 months. One hemisphere would bake in continuous sunlight, while the other froze in eternal darkness. The sun-facing side would experience temperatures well over 100 degrees Celsius, hot enough to boil remaining lakes and rivers. The dark side would become so cold that gases would freeze out of the atmosphere. Only a narrow twilight zone between these extremes might offer survivable temperatures, but it would be battered by constant violent storms. The magnetic shield collapses. Perhaps most terrifying of all, Earth's magnetic field would collapse. This protective shield, generated by the movement of liquid iron in our planet's outer core due to rotation, protects us from deadly solar radiation and cosmic rays. Without this magnetic field, the solar wind would begin stripping away our atmosphere, just as it did to Mars billions of years ago. Any life that survived the initial catastrophe would face bombardment by lethal radiation from space. Historical evidence shows us what happens when the magnetic field weakens. About 42,000 years ago, during a magnetic reversal, the field strength dropped to less than 6% of current levels. The result was ozone layer destruction, electrical storms, climate chaos, and mass extinctions. Understanding the impossible. Here's the reassuring truth. This scenario is physically impossible. Earth possesses enormous rotational momentum, approximately 7.07 times 10 to the 33rd joule seconds of angular momentum. The law of conservation of angular momentum means no known force in the universe could instantly stop our planet's rotation. Why Earth actually slows down. Earth's rotation is slowing, but gradually. The primary culprit is tidal friction from the Moon. Every century, our days get about 1.7 milliseconds longer. This process has been ongoing for billions of years. Scientific evidence from fossil shells and sedimentary deposits reveals that 600 million years ago, Earth days lasted only 21 hours. During the age of dinosaurs, 70 million years ago, days were approximately 23.7 hours long. The Moon is slowly stealing Earth's rotational energy, converting it into orbital energy. As Earth slows, the Moon moves farther away at about 3.8 centimeters per year. This elegant cosmic dance will continue for billions of years. Recent puzzling acceleration. Interestingly, Earth has been spinning slightly faster in recent years. Since 2020, we've recorded some of the shortest days in modern history. July 5th, 2024, set the record as the shortest day ever measured, finishing 1.66 milliseconds faster than 24 hours. Scientists attribute this recent acceleration to several factors. Changes in Earth's core dynamics, atmospheric variations due to seasonal weather patterns, glacial melting redistributing mass from poles to equator, seismic activity like the 2004 Sumatra earthquake that shortened days by 2.68 microseconds. If Earth were to slow down gradually over millions of years, the effects would be dramatic, but not instantly catastrophic. We'd experience increasingly longer days and nights, disrupted circadian rhythms affecting all life, altered weather patterns as wind systems change, problems with satellite technology designed for current rotation speeds. Eventually, tidal locking with the sun. Modern climate change is now measurably affecting Earth's rotation. Since 2000, melting ice sheets and glaciers have contributed to lengthening days by about 1.33 milliseconds per century. As ice moves from poles to oceans, it redistributes mass farther from Earth's axis, slowing rotation like a figure skater extending their arms. While Earth suddenly stopping rotation remains impossible, this thought experiment reveals the incredible interconnectedness of our planet's systems. Our 24-hour day, stable climate, protective magnetic field, and the very shape of our continents all depend on that steady spin we take for granted. The gradual slowing that is actually happening reminds us that Earth is not static. Our planet is a dynamic system where rotation, magnetism, climate, and life are all intimately connected. Understanding these connections helps us appreciate both the stability that has allowed life to flourish and the changes that continue to shape our world. So the next time you feel Earth standing still, remember, it's spinning at over 1,000 miles per hour, creating the stable, habitable world we call home. And that's exactly how we want it to stay.